Hello, this is Akar here, and in this video, I will be discussing why noise is a problem in designing chips. And as you can see here on the bottom part of the screen, there's it mentions white noise, pink noise, and brown noise. Those are different types of noise. So here on this slide, I mentioned why noise kills chips. So first of all, when chips get when chips get smaller, less than 10 nanometers, noise starts to make electronics fail, and that includes chips. When billions of transistors are connected together, this is a part of the chip design process. The distance between the transistors starts to become smaller. See, the transistors are very close to each other, and this stops the normal signals from being transferred, and this leads to noise. And as discussed before, noise causes chips to fail. Within the chip industry, you see current like EDA tools, electronic design automation tools. They can detect the noise, but when it's too late, essentially, at the very last stage of the design process. And by that point, you can't really fix the noise. The chips have to be decomposed by this point. Thrown away. Noise in chips. Now here I will discuss why it's a problem. Noise. So first of all, it causes the hardware in the chips to degrade at a faster rate than it would without the noise. And besides that, it also causes failure in the logic system of the chip. This prevents the chip from functioning properly. This is known as 2025's biggest challenge within the chip industry. That is noise. Noise is a big problem in chip design. Now I'll discuss some possible solutions and methods, and then ultimately, at the end, I'll discuss the ultimate solution, what I think is the best method to solve this problem. So current solution methods, and current refers to as of December 2025. So the methods for detecting noise is to isolate the transistors, to not get them very close to each other. And what this is supposed to do is it's supposed to prevent the noise from initially starting. It's not even supposed to happen. Uh, Sometimes you also have capacitors to level or stabilize the voltage. But on very small chips, this is a problem because it consumes too much power, more power than would be expected, and it doesn't always solve the issue right off the bat. These methods do work when conducted on individual chips. So, yes, these methods do work eventually, but on individual chips, so one on every single chip, they have to be done. But they don't work when looking into a lot of chips, like for say mass production, for example, or when you have some chips that are in analog and some digital chips, then this doesn't work. There's a challenge there. So essentially, what happens here, like a summary, if you add more protection to the devices on the chip, so that refers to adding more devices like the capacitor and all that. It makes the cost to make these chips go up, and more power gets used, which is an unwanted side effect. And these methods do sometimes help out, but not always. And as you can see here on the bottom of the screen, there's an image. It mentions, so on the left side, there's a graph showing the test time in minutes it takes to detect noise and the amount of test coverage that you get. So yeah. Now I will discuss the ultimate solution of what I think is the best method to solve this problem. So the ultimate approach, the way I got this is through weighing different options and considering different methods, and what I think is the best one, most effective one. So and this is again as of December 2025, the best method is to move the verification process to check for noise to the beginning of the design cycle. When it is detected, the noise can still be fixed. See, so essentially, you're reversing the design structure instead of doing the verification at the end for noise. You move it to essentially the beginning, specifically the logic part of the design, and this allows for if there's noise detected, you can still fix it, and it's still fixable, and the chips don't have to be thrown away if it is detected. And if, say, the noise is detected, the way you deal with it, the way you fix the chips, there are two main solutions. You could either increase or decrease the size of the chip itself, because the size helps the it impacts the noise, or you could um, uh, try to predict noise patterns. You could essentially try to redesign the logic within the chip, and that also impacts how the noise works in the chip. So that's that. And the conclusion is that detecting noise before the logic is designed increases the rate of successful chips by 40%. And successful refers to chips that either don't have noise or are able to recover from it. And that refers to, they get the noise fixed without having to be thrown away or anything like that. Um, Besides that, it's not just technical advantages like technology related stuff, but it's also has some economic advantages, such as it prevents money and time loss from those failed designs where the noise was detected and could not be fixed. So, yeah, noise is a very crucial part in chip design, and I think this is the ultimate approach to it.